of you submitted the assignment 6 constant satisfaction problem? Okay, so Bhaskar is saying he went home. Okay. Rasmi is saying she submitted assignment 6. Fine. So, is anyone have any doubt from that assignment? It's a very crucial part of AI constant satisfaction problem. And whatever we will do now, it's again you will have to satisfiability problem SAT. So it is like a follow up the previously whatever you have done. So that's why I'm just trying to summarize. Right? Is my skin visible? Can anyone please confirm? Are you guys are hearing me or just join the session or leave it? I'm asking something. Please reply someone.
Yeah.
Muni, is my skin visible?
Yes, sir.
Yes, the screen is visible.
Yeah.
This
Yeah.
is
Yeah, please do interact. This session is for that purpose. Otherwise, no need to, you know. There are a lot of lectures on YouTube, and you can obviously see and work out on those. The main motivation of this session is to interact with someone, discuss your idea, have a feedback on those things, how you approach the problem, those things, you need to tackle. That's the main aim of this course. So please do interact. This is the motivation of the work. So I was talking about constant satisfaction. That's a summary of that, and so that I'll go to the current week, whatever we are doing. I'll not discuss the current week assignment problems, but I'll discuss few previous problems last year, so that you can have some idea how to solve and approach logic quizzes and problems. So I told in last meeting also, everything in AI is a kind of some search problem, as mentioned by Professor. So he says you give any problem and he can, transform into search problem, because everything is it's like a searching problem itself. If you see, just think, have a simple perception. What you want from an autonomous model. You want a model that you give some input and it give you some output, desirable output, process the input. So it's like I is going to a model M and finally it is being converted into O. So I is becoming I dash in model M, and that M dash helping to map it to some O. Is as simple as that. So this is the simple, synergy you can have like that. Finally, it's mapping from. I really don't like people used to come at after. So I request everyone, please don't try to join after 17. I may not entertain you to end you, so I may leave you. So I get disturbed whenever I go in slide. I get a pop-up for that. So please try to enter the class before 17. So I was talking about everything in AI is a kind of search problem. So very simple synergy. You want to map I, that is input, to some output O. And what you are doing, you are just transforming I to I dash or I double dash so that it can be easily mapped to O. For example, if I have to say, let's say sentiment analysis. So you are giving an utterance and trying to find out whether the sentiment is positive, negative, or neutral. So I am very happy you want either of them. It's a positive, negative, or neutral. So given a sentence S, you want to map it with some output, desirable output, which is negative, positive, and neutral. So neg, let's say that's what you are doing. So you are taking the input, you are processing it so that you understand, oh, there is a very good and most likely the sentence is going to be mapped with the positive thing. So everything in is AI is a kind of search problem. You give me any problem, whether it's a sentiment analysis, whether it's a diagnosis problem. For example, my research area involves around healthcare. So it's like a conducting a symptom investigation, and based on the conducted symptom investigation, it has to diagnose what patient is suffering from. So it can also be think, people can think it as a search problem. So input was patient self-report, hey, I'm suffering from cold and headache, let's say. Based on that, you need to ask them next symptoms which is most appropriate. For example, cold and headache, someone said, then most likely you can ask, do you have also cough? Do you have also fever? So it's like given previous symptom set S, it has to map with another symptoms which is most probable given the previous symptom set, right? And once the model finds, okay, I have enough symptom set information S, which contains cold, cough, fever, headache, leg pain, back pain, and all. So can I map with some output O? So it's like given the symptom set, it has to map with the sum of the any one of the diseases. There could be multiple diseases as well. So it has to map with, let's say there are 10 diseases in the system, then it has to map with which one is the most appropriate given the context, given the symptom set. So this is how everything in AI could be converted into search problem. So representation matters the most. As I was saying, I is going to O, so in it's becoming I to I dash, and finally it is becoming mapped with the O. So that I, how you represent your input matters the most, right? Because that I give the whole information about the state, what it contains, and what is the most appropriate O that should be mapped with that. So representation, so this state representation you need to do in a such a way that whatever the crucial information that requires to be mapped with O should contain in I. And then the model task is to process, identify that part, and give more priority to that part, and finally map with the O. So if you could think of very deeply, it is again take I, take again, find a subset of I, again searching problem, which is useful. Otherwise, there will be some redundant information. Take that small subset of I and then process it. You processed it and then you need to map it with some output state. So information processing effectiveness hugely depends on effectiveness. That's true. You give me any problem and it depends on like that. So these are the trivial definition you might be knowing. What is state, what is the goal state, and what is the solution. So with a solution is a assignment of variable which must satisfy goal state given the domain information which has been provided into state. If anyone have any doubt, any suggestion and remark, please feel free to pause me in between. So it's completely fine to give me a pause and have a discussion around something. This is the thing. So just I was saying about everything in AI research problem. Please take this with you know with deeply think whenever you're trying to solve an AI problem. Go with that perspective, and definitely is going to help you in formulating that problem in an effective way, so that optimization of the solution could be done easily and effectively. So finally, this is the model. AI model or autonomous model is something like that. You give data to a learning model, the model would be ready, and then you give the query and the inference will be happen. Inference means testing. Your model has been learned. Now you give the query and it will give you the prediction. Examples could be such problem, MDPs, games, factors. MDP is a Markov decision process. Bayesian networks, what type of model do you use? So this depends on the model, whether it's a search problem, games, factors, graphs, and all. Some modeling paradigms you might be knowing. uh, State-based models, search problems, MDP, games. So I was talking about how you model your state, whether it's a state-based model, whether it's a variable-based model, or logic-based model. There are three main these kind of things which will be which you are learning and going to be learning next weeks. So finally, state-based, variable, and logic-based. This week theme is logic-based, which I'll discuss in more detail. So two goals of logic language, the representation and region. As I was saying, I used to stress the sentence more and more often. So finally, it's mapping of I to O. So I is the representation which is going to be processed as I dash and becoming mapped with O finally. So I is the representation. You are making I to I dash by doing some reasoning. This is what reason with that knowledge. it is becoming IDAS, and then you are mapping easily with O. So this is like a model, tell the information, and then this is the training time, and then you use ask question. It's like a query, and it will do the task. So it's like a training and inferencing time. Heterogeneous information means different kind of data you have, such as images, audio, and text. How deeply you do, reasoning, how intuitive make your input representation like I dash, your your model, performance will be much better because it understand that text, it understand that input in depth. Now it's satisfiability priority, and this week theme is like, so what is satisfiability? So it's you'll have some boolean formula, you'll have some formula, let's say f. Now you need to find out a set of assignment for those variable that satisfy at least one of, you know possible combination would lead to that problem satisfaction, that function satisfaction. So there are these kind of mapping. Mapping is like a propositional symbol is like a variable. Formulas are the constant, and models are the assignment. So you want to make a model. You want to do a finally assignment. What you have to satisfy, you need to satisfy the formula. Formulas are nothing but the constant. There are two kinds of constant: domain constant, and another one is the whatever the formula you have given to satisfy. For example, it should satisfy x plus 2y should be odd. Now you need to have two kind of satisfaction you have to do. For whatever x and y range I have given, x must be less than 10 and y must be greater than 10. So these are known as a domain constraint or the state constraint. And finally, you need to satisfy x plus 2y should be odd. So that formula constraint is that you need to select such y with the given constraint x should be less than 10, and y should be greater than 10, so that finally x plus 2y should be odd. So please remember these two kind of constraints you need to always satisfy even in these big problems. So I discussed last time of the graph coloring problem. What does that means? How you do that? Algorithm we discuss in more detail. So it's more often you go with like whatever you have more variable, you start with that and try to go in narrowing down the space, and do the the final assignment. So variables are the regions here, so you have to do. Domains are the colors allowed, RGB, red, green, and blue, and constraint that the adjacent should not have same color. So last time we discussed. Is there anyone have any doubt in this section? Please feel free to interrupt. These are very classical problems which we are going to face in coming assignments and also in the final exam that will be in April, I guess. When will be the final examination? Anyone know? Okay. It's a 12-week course, so maybe around April or May something the exam would be held.
April
April
29th, sir.
29th.
It is
29 April. Okay, cool. So these are the here n queen satisfaction problem. Will there be any solution in 3x3 chessboard? Anyone have any answer for that? Will there be any solution in 3x3 chessboard for so that two queens should not attack each other? Please do interact. If you see my last session, we mostly talk about the problem, how you approach them, how you think about those, where is the misconception, and how can you work on it. If you see my last session, we always discuss about the problem they solved. I didn't do anything, so I gave this problem, and they try to solve how to handle this. How we wrote some algorithm for that and like that. So this is the main theme of this kind of workout session where you need to have involved in problems. Even I can give you the problem, you need to solve it, how to do that. For example, last time we tried to solve this 4x4 chase problem through finally implementation. So no. what are the constraint in chase problem? If you know, there are three constraint: the diagonal, row, and column. Three column, these are there. Row and column is quite easy to know that it should not x and y should not match. And but for diagonal, you need to think what pseudocode you should write that to be satisfying that. Do anyone know how to do the diagonal, to check whether for let's say the two queens are x and y and x dash and y dash, how you know that they are, satisfying all the constraints? They are in not same row, not same column, not in the diagonal. Uh, Please say at least this part is easy to say, row and column part.
Sir, can you please explain once?
Can,
Without listening to class. Last time.
your voice is not clear, Muni. Are you traveling or what?
Sir, no, sir. Sir, can you please explain it once again?
Should I
Six.
explain the question again? Are you asking me to repeat the question again?
Sir, we don't know how to solve that type of problems. Can you please
Yeah, definitely. That's
explain
that's
one
what
type
I
of
was.
concept?
Yeah, yeah, sure. So, how to tackle this kind of problem if you wanted to know, right?
Yes, sir.
So, uh, you know how to play chess?
Sir, little more.
Little bit, you know chess. Okay. The main thing about to play a chess is I am not going to in rules of the chess, but the three constraints that usually put on queens are if two queens not should not attack each other. Otherwise, it is like you cannot go in that situation. It will be uh, if you don't have option to put your queen at some place that should not contradict, then you mean you have lost, right? So you get 16 chances or something like that. If you make the moves in such a way, then it will be draw. So two queens attack each other means either they are in same row, either they are in same column, or they are attacking each other in a diagonal way. So for example, if you see my slide here, these two queens are not attacking each other. They are not in same column, they are not in same row, they are also not in diagonal, if you see. But if I'll put the queen here, then it is attacking each other. If I'll put the queen here, it is attacking each other. If I'll put even the queen here, it will be attacking each other. So we need to we not need to don't go there. We need to leave those positions so that it should not attack each other. So if I'll ask you to write a code, write a function so that it should satisfy this constraint, should not be in the same row, should not be in the same column, and should not fall in diagonals. So how do you write it? So if x and y is the position of one queen and x dash y dash is the position of another queen, how do you do that? That we'll discuss in last if call finally how will you write the code to satisfy those things. So is there anyone volunteer last time who did in the my last session? I forgot one is the Bhaskar, another guy was someone. Seems like he's not here. Okay, let it be. So have anyone attended the any other TA session? How they used to record the session? Is it like a Zoom or Google Meet only they used to do?
This Google Meet, sir.
It's a Google Meet only. So how they used to record, do you know? Okay, seems like.
Google Map.
Yeah, Balaji, do you want to say something?
Yes, sir. It was done in Google Meet, sir.
So how they used to
Where
record the session?
session, yeah, from mails.
From mail, it would be recorded.
It was sent a mail to us. Then it will be done to 7, like 8 p.m., 6 p.m. Then it will be starting the classes like that.
No, no, my question was different. My question was how they record
No,
that session. It's not about.
no,
I
you want to record this session. Now
Yeah,
you want to record this session.
yep,
Then in the bottom menu there are three dots.
yeah. There are.
Three dots are there. Na? On that you click.
Yep,
There
I
you may
click.
get option to record this.
Is my screen visible? There is no such record option. It
But who is
usually.
presenting? Generally, who is presenting? They will get that option. Others won't get that option.
Okay, okay,
Sir, nowadays this record option is disabled in Google Meet.
Oh,
okay, okay.
If you have the
then it is
paid
not
version,
possible.
then you can record.
Exactly.
Okay.
G Shoot it allows you to record. So that's why I'm using TLDB, which used to record, but NPTEL authority is also asking you, to upload the session on
No.
YouTube, and with I'm not able to download the video. I'll give you the link,
Okay.
online link, but I'm not able to do download at the local and upload in a YouTube. That's the problem I'm facing.
Some other software you have to use to record
Yeah,
this.
yeah,
Then
true, true. I need to use some
free.
software, screen recorder or something like that, so that it.
Uh,
Okay, so I was talking about how satisfy the constraint. So if let's say the diagonal row and column is very easy. If x and y and x dash and y dash are there, then x and x dash should not be equal. Y and y dash should not be equal. So row and column becomes very clear that if it is not same, then you are not in the same row or same column. That's quite sure. Now come to the diagonal part, so which is a bit tricky. How will you ensure that the two queens are not in a diagonal position? So this kind of questions would come in your final examination. They'll ask the question, what are the pseudo code for justifying or satisfying the two queens are not in same diagonal, and there would be four options. Some scripts would be there. You need to select which one makes sense for the given scenario. So you need to check it. If you see, let's say this is the I comma j position, and obviously this one would be I plus one j plus one, isn't so? If you see, you need to. It's not theory. AI is not theory only. We need to also do implementation. So this is I comma j. Then this position is what? This position is uh, if I have I am here I, let's say I comma j. How will you go to this position is I'll go up and then right,
minus.
right. So in both coordinate I'm doing +1. So up diagonal would be for x and y. Up diagonal would be x plus 1, y plus 1, x plus 2, y plus 2, x plus 3, y plus 3, so that x plus whatever I'm adding, it should be less than 8. And then from there onwards, you can see that x plus I, whatever you are doing, y plus I. So x plus y plus I should not be equals to x dash, y dash. So this is the idea how you will finally check whether they fall in same diagonal or not. Just a second. Hello. হ্যাঁ কৃষ্ণ ওই NPTEL এর TA সেশন আছে একটু পরে ফোন করছি। হুম। So I was talking about diagonal satisfaction. So you got it how I'm deciding. Whoever asked Muni, did you get the? So whenever you try to solve some problem, you need to do think analytically. As I said, it's a position only I comma j. Then what will be the position of this coordinate? It will be I plus one j plus one. If I have to go down diagonal, it would be I minus one j minus one. So in that way, you can make work out on a single problem, work out like a case study, and then you write a generic code for that. So this is how you need to tackle those kind of problems.
Thank you, sir.
So this is one classical problem of crypto arithmetic, and most likely you will get one problem of this kind in your final examination. So variables are TOFUR. you need to do assignment from 0 to 9 so that it should satisfy this constraint. 2 plus 2 should be 4. And this is how you need to overall satisfy this constraint. O plus O, if you do, it should be 10 times more than x1, whatever the position you are getting it here. So please work out with this example so that you will have the clear idea what would be assigned for T, W, O, F, O, U, R. This character should be assigned with some numbers from 0 to 9 so that it should satisfy the thing.
Please repeat this. I could not get the point here. Domains means what?
Domains means what possible value you can assign to these variables T, W, O, F, O, and R. These characters, what way possible values can be.
For please, Gayatri, mute yourself.
So, for
So here,
example,
for each character T, W, O, F, U, R, we have to assign one numerical value.
exactly, so that it should satisfy this equation 2 plus 2 should equals to the 4. So, give you
This equation will be given.
yep. So, x and y is the variable,
Okay.
and whatever x and y could have. For example, I'm saying x could be in range of 1 to 10. 1 to 10 and y could be in range of y, let's say 30 to 60. 60. Then if I'm saying x plus y should be x plus 2y should be odd.
Okay.
Let's say this is the constant satisfaction problem. So x and y are the variable and these are the domain. X could attend number from 1 to 10. 30 to 60. Let's say these are inclusive. Then this constant you need to satisfy along with that so that whatever you value select so that it should satisfy this thing x plus 2y should be odd.
Odd. Okay.
So this is domain and this is your final formula. So here also if you see 0 to 9 is the domain and 2 plus 2 should be 4. This is your final function that you have to do. So this is how you need to do it, and these are the constants what says how do arithmetic calculation, crypto arithmetic. O plus O is like R plus 10 into x1.
So x1, x2 are again in the same domain. Huh?
Yeah.
Okay.
So real world some CSPs are constant satisfaction problem are your timetable calculation. So it's a very difficult problem. People, I don't know how they take it, but I remember I was in third year and my professor gave me this task to do timetable calculation. Given the professor constraint, you need to make a timetable. This is a very difficult problem. Different faculties have different priority that they should take only 2 classes on Friday. That should not be consecutive and like that. So you need to satisfy all of them and make some timetable. So these are some real world satisfaction problem. Transportation scheduling, factory scheduling, those kind of things are there. So these are the domain. As I said, unary means it can have only one thing. Binary, it's a constant involve the pair of variable, and higher order maybe 3 or more than that. So this example we worked out in last session how you can assign. So this is like you have to assign color. What you could do, you can assign red, green, or blue here in 3. Then you go depth. Let's say you are breaking this branch first. So you are assigning green, you are assigning blue to this position. You are going in depth. So it's like a depth first search. The black magician, I'm not going to add you. So constraints are as I said, constant satisfaction, you should think it as a very simple problem. X plus x2, here it's given. It's just an equation that you have to solve. I solved few problems how to do that. So this is one example that it came in last year exam, I guess, or something like that. Now coming to this week thing, propositional logic and satisfiability. So if those who have watched the video of this week, they may have the clear idea of what I'm talking about. Otherwise, I'll give you the brief description what is all about, and then I'll go for a few problems. Knowledge representation. People used to call sometimes data also. Data is also like a condensed form. Knowledge is a condensed form of data. You are finding some pattern out of data, which is a knowledge. So it's more of a knowledge is information, analogous to information. And data is data. Data is means you have a lot of what could I say? So useful data is information. Useful data is a kind of knowledge. So here, if you see, represent knowledge about the world in a manner that facilitates inferencing. Inferencing means tasting, drawing the conclusion from knowledge. So you will have given, you have, for example, I have a 5-year child, so I'll give them set of knowledge and then say what to do in the given scenario. So what he's doing, he has some data, he has and then based on that, he's acting in inference time. So this is what knowledge representation is. Whatever the knowledge I have given, how do you represent it in some mathematical form? For example, here it's like x is greater than equals to 5. X should be more than 5. For example, let's say you are going to country C where minimum currency is 5. So you need to write it into maths form. It will be x should be greater than equals to 5. So this is how you express an information in mathematical form. In AI, typically based on logic, probability, logic, and probability. Logic, how you express your, info knowledge in mathematical term. Probability, you all of know how it models uncertainty given the scenario. And if you combine these two things, logic and probability nowadays involve in various AI problems. So these are the typical kind of problem that has been seen in last 10 years, based on only logic, based on probability, and based on both kind of thing, logic and probability. So knowledge is fundamental to the logic, and nowadays data have become a fuel. You must have heard data has been become a fuel for deep learning models. This is the deep learning era, but I am still a great fan of knowledge. How will you represent the knowledge matters. Along, you have data, that's good enough. Take the data, but along with that, also infuse some external knowledge, infuse some knowledge base along with that knowledge. Then it will learn the problem in more effective way. It will find out the pattern out of data more easily. So loosely, if I can say knowledge is like a pattern out of a data. It should not be equivalent, but in loosely term I can say it's knowledge is like getting a pattern out of a data. For example, if I'm saying every prime number, every prime is number is odd other than 1, isn't so? So there is that pattern kind of thing. So this is a kind of a knowledge you will have. So it's like a number would be prime if and only if it is not 1, then it will be definitely, it will be an odd number. So if I'll ask whether 43 is a prime number or not, so easy thing you can do, whether it's odd and even, then you, if it is even, then more, you can easily say, no, this is not going to be a prime. This knowledge I'm giving. Your problem was to find out a prime number, but additional knowledge I gave that I'm just excluding 1 for as of now and something. 2 is also a prime number of what? It is divisible by itself and 1, right? So there is a boundary I might that I'm just excluding there, that loop used to call boundary cases. So I can say all those prime numbers are odd. So if it is a even number, more it will not be a prime. So this is a knowledge I gave, so it will solve the problem easily. What are the components of KR? Components are syntax. How will you represent a knowledge? If I'm saying, let's say, you shouldn't, you shouldn't, you should carry umbrella if it seems a rainy day. Rainy day means if humidity is A, less than A, and let's say some temperature is B. So So if I'll ask you how you represent this into a knowledge, so you'll express into some number. You'll need to have some variable, and you'll do some put it into to logical form. So you should carry umbrella, and this will be your inference condition. You will express it. X is like a humidity and y is a temperature. You'll give some constant over it. So this is how you represent your knowledge. So there are two kinds of two things are there: syntax and semantics. Syntax means how finally you are going to express that one, whether it's a number, whether it's a logic, whether it's a set of character. Semantic is what it is conveying. X greater than 5, x should be x is more than 5. This is the semantic, what it is meaning, or what meaning it is conveying. Inference procedure. Inference is like a tasting. I gave you the knowledge, you find out some syntax, you express that semantic in that form. Finally I will say, okay, based on that information, can you do inference? So how will you do that? It's algorithm. You will have to check whether it's satisfying or not, and then based on that you can say whether uh, um, this given formula is satisfiable with the given knowledge or not, something like that. So these three things you will find into your assignment and things. What is the satisfiability, validity, and entailment? These are three different things people sometimes use to intermix this. So S is your constraint, let's say. S is satisfiable if it is true in some world. World means domains. Let's say S is a function of X and Y. Very simple, X plus 2Y, whatever the example we took it, and x and y have some domain constraint, whatever I've given there. X should be greater than, x should be in 10 to 20, and y should be in 30 to 60, right? So the world is x. This is the world. Domain information is world. X should be in 10 to 20, and y should be in 30 to 60. This is the some world. In that value, S is satisfiable if there some number exists which satisfy x plus 2y is odd. So this is the satisfiability problem. What is satisfiability? Now it must be clear. If you have any doubt, please let me know. So you can write it as f is, that's a function that you have to satisfy. F should satisfy. Along with that, it should follow whatever the variable given b comes from same domain, whatever it has given. S is unsatisfiable if it is false in all worlds. There should not exist a single set of variable that satisfy function f or s. Valid means it is always true. It is always true. And S1 entails S2 means whenever S1 is true, S2 is also true. This is the entailment problem. So these four things should be very clear. Entailments is a very classical problem of natural language processing. My research area evolves around that. So I can totally relate with that. How this kind of information are relevant with that. So I'm saying I'm very happy is positive. I'm happy is positive, then definitely I'm very happy would also be positive sentiment, right? Because very is just an intensifier over happy. So it would be always positive. So CNF and DNF are the two ways of expressing logics. Logic is, you can call it as in terms of X and Y. Anyone know what is CNF and DNF? Who have done the lecture? At least the full form. CNF is conjunctive normal form and DNF is disjunctive normal form. These are two powerful representation to have the expression of causes. No, okay. So CNF and DNF. Let me explain you what it is. Conjunction means and, you think it as a disjunction means or. So conjunctive normal form is conjunctive normal form. So there would be always conjunction in between. If you see and is there between every clauses. So this is CNF. How do you identify whether it's a CNF or DNF? There would be clauses. Obviously, this is the clause 1, C1. This is the clause 2, C2, and this is clause 3, C3. All clauses should be connected with conjunctions, means and. If clauses are connected with and, this is CNF. If clauses are connected with disjunctions or then it is known as a disjunctive normal form. So now it should be clear what is CNF and what is DNF. So there used to come some problems, convert DNF to CNF, convert CNF to DNF. So if you know the Boolean logic formula that I didn't write in the slide, because many of you know Boolean algebra, so that's why I didn't write. You need to know the rules and then you can convert DNF to CNF and vice versa. For example, I took this example to convey with you. So it would be very easy to follow if you know the set of rule. For example, association rule, distribution law, De Morgan's law, and all those things. Then you will be able to follow it. So it is here. It is in DNF form because all clauses are connected with disjunction. Disjunction means or, conjunction means and. So you need to convert this form to this one. How do you do that? This is a given a proof. So A and B, or B and C, A and C. So you also need to know the meaning of these clauses. A and B, what I'm saying here, it's like A is true, B is also true. So obviously if A is true, B is true, then A and B would always be true. If A is false, then A and B would be false, because for AND operator, if you want to make it true, then both should be true. In other cases, if any one of would be false, then AND operator leads to false. So this is how they have converted. If you see A and B or B and C, and just so they first separated this A and C outside, and then they opened this A and B. This is the rule for A or B. How do you write it? So A and B, or B, and then it clubbed with A here with A and B, and then C. So as I said, you need to know the formulas. I could have written here all the formula: association rule, distribution rule. Then you could association rule. Then you will be easily able to do that. So this is a kind of assignment or the exercise you should do after the lecture, how to convert them, because this kind of thing would come in the exam. They'll not ask you to convert, they'll ask at the ith step, let's say, what would be there. So this kind of thing they used to ask. So don't think only with the mathematical formula. So what it conveys also, it should be clear. P both way implies Q, means P implies Q as well as Q also implies P. In maths you must have heard if and only if. So double implication is if and only if, and single implication is if. Any doubt, any question till there?
So can you explain the last one? Not PQ is identical to P not Q.
This equation, sir, are you talking about
Yeah,
negation
yes,
of
yes.
P?
Yeah.
Yeah, so
How it
let's
is?
work out on this example. So I can prove it through uh, Boolean algebra. Let's do that. That would be interesting to do it there. If someone would volunteer with me, then it would be very much interactive. I used to do this kind of thing. So you have two variable P and Q, right?
Okay. Yeah.
P and Q, and now you want to design P. P double implication Q is like P implies Q, and Q implies P. So let's write
Yeah.
it. P implies Q.
కాసేపు ఒక 5 నిమిషాలు ఆగు.
Yeah, someone saying something. I don't have much space, so I am writing and then I'll explain how to explain.
That is only negation of it, no?
Exactly, because
Uh,
this was here, negation of
no,
P implies Q.
minus, yes, okay, we can understand.
And now it is here P double implication. Double implication didn't work. Oh, it worked. P negation of Q. So Boolean algebra is the one of the powerful way to express the logic, prove it, disprove it, and everything like that. So for P and Q, how many combination could be possible? It would be four: true, false, true, true, false, true, and false, false. Now when these two here it is saying identical means whatever the truth table you will have for both all the combination, it should be same. So for all combination P and Q, whatever form this formula will lead to, whether it's a true and false, this should also be same. This is how you prove it. If any of combination would not be equal, then you can say this doesn't satisfy, this doesn't work. This is one way you can prove it. So for P and Q, it's like a true and false,
Uh,
true and true, let's say. Yeah,
okay.
please go ahead.
How can we take 0 ones? This will be more easier to understand.
Sure.
0, 0,
0 0
0, 1, 1, 0, and 1, 1. One more row is to be added.
exactly. 1 1.
1.
Now these are, if you see, and of P implies Q and Q implies P. P implies Q could also be written as, if I remember, negation of P or Q. Can anyone confirm that it can be written as P implies Q can be written as uh, and of P, negation of P or Q, something like that. I couldn't able to recall completely. Otherwise, if you remember P implies Q for 0 and 0, what it would be? Can anyone tell? Then I can go with, or otherwise I'll do
So that was
simplification.
given in the third row.
Yeah,
P
yeah.
implies Q is P and Q, or negation of P and negation of Q. That we can use here, no?
Oh, this equation you are saying
Yeah,
I
third
can use
one.
it.
Yeah,
Third one, third one.
third one we can use here.
Yeah, but it's quite, it's double way implication. So negation of that we can, yeah, true. That we one. Let's do the maths and then do the negation. So if you see P implies Q, just we are doing negation over it. So let's calculate this one and then we can do negation over it, right? So P and Q for 0 and 0, it will be 0. For
Mm.
negation of P, negation of Q, it will be 1 and 1. So
Mm.
it will be also 1. For 0 and 1, it will be 1. And then
Mm.
negation, it will be 0, right?
Mm.
This one will be 0. Am I correct?
Yeah.
Now we need to calculate this equation P double implication negation of Q.
Mm.
So for that, we could use again this equation, but you need to replace Q with minus Q
Yeah.
in order to make sense.
So 0 and 1 means it becomes 0, or 1 and 1,
Mhm.
0. So that will be 0.
That should be 0. So it satisfies this one. You can, if you calculate, let's say randomly, let's calculate for this one and say whether that match or not. So for
Okay.
1 and 0,
So by using truth table, probably it will be very easy to prove. But
yeah,
mathematically, as shown on the left side, proof,
yeah, yeah, yeah.
the fourth one, the last one, can we prove that much
Yeah, definitely we can
easily?
prove. Yeah. We can even prove with the
Okay.
this one also. So let's say with the truth table we have proved it.
Okay.
Now let's try with you are saying with equation, can we prove it?
Yeah.
I'm not very much thorough with the formulas, but whatever the formula we have given, we can break it and
Then
try with
then
it.
then let us go through this truth table only for another combination of P and Q.
Okay, sure.
Then it saves some time.
Yeah, yeah. But why not to also try? I was thinking to go there. Yeah, let's try one combination. So I was thinking P double implication Q will replace with this equation. Negation of P
Hmm.
double implication Q and then put negation here.
Hmm.
And then can it be converted to this one? I was trying to thinking like that way. Did you get my idea what I was saying? So we'll do modification over this equation given this previous three one. So in that way, you can also prove that whether it's equivalent to P double implication minus Q or not. In that way, you can also prove it.
We have to
Negation of
work on it. We have to work on it. It will take some time.
G. Yep. Yep. Negation of P. Negation of Q. Negation of Q. Okay. Yeah, we need to work it out and then do. So formula you need to thorough. Otherwise, you can have just assignment easy way to do and find out whether that work or not. Otherwise, you need to become thorough. We can try with this combination 1 and 0,
Okay.
let's say.
Okay.
So for 1 and 0, it would be, for 1
On
and 0, it would be 0.
0.
It
So
would
as
be,
next column will be 1.
it would be
It will be 0.
0 and 0, obviously 0. And then this would be 0. 0 and 0, 0. We need to negate it, so it would be 1. Am I
Yeah.
correct?
Yes. Yes.
Now you need to see whether it is
So
0 or 1. So P double implication minus of Q.
2 and 1. That also will be 1.
Yep. So these four combinations, if you prove both truth table are identical, then you can say, yeah, these
Yeah,
are
satisfied.
to satisfy these things.
Yeah. Okay. Thank you.
So I was talking about what is satisfiability problem. Satisfiability problem is given an equation, you need to find out an assignment that satisfy that equation. And if it always satisfy for all combination, it is a tautology. If every variable assignment is satisfying that given function phi, then it is a tautology. If there exists at least one, not all, then it is like a satisfiability problem. If there is no variable assignment that can satisfy phi, then it's unsatisfiable. So this kind of question would come in exams. So there would be a phi function and ask whether it's a tautology satisfiable or unsatisfiable. So all tautology equation are satisfiable, isn't so? So these kind of the question they may also ask like a true and false. Obviously, it is tautology means all they're all possible equation leading into true. So there is at least one equation that is going to true. So this become all tautology are also satisfiable because there exist. And tautology and unsatisfiable is obviously contradictory to each other. What about the satisfiable and unsatisfiable? They are also contradictory. What else combination we can see about? No, these are the three combinations. So this is a pretty informatic side. If you see what is syntax, which arrangement of the symbols are the legal. So syntax is like that. Semantics is what symbols mean in the real. I discussed about this slide earlier. So these are few problems that you need to work out with that and see which one is in the propositional logic. What is the identity of conjunction and disjunction operator respectively? This is was the question, and these are the option true false, true false, true false, false true, false false, and this is why. In propositional logic, what is the identity of conjunction and disjunction? So question is, uh, what are the identity for conjunction and disjunction operator? So what we did, we just let's draw the truth table for PQ, two variables we have, and we drawn it for conjunction. Conjunction is and disjunction is or. So these are the combination which is becoming true for the identity operator. Whatever the value you are giving true, and it is also becoming the conjunction are also becoming true. So these combination true for conjunction and false for disjunction. So option B would be correct for this given question. If this anyone can work out with that, then it will be good. So S1 is negation of A or B. S1 is saying either A is wrong, means false, or B is right. This is the meaning. You should don't only read equation. You should also get meaning out of it, so that whenever you convert into language form, you have to explain with the case study that it could be done. So negation of A or B means S1 statement is saying either A is false or B is true. S2 is saying A implies B. Which of the following is or are tautology? So these are the four combination they have given, and asking which one of them would be tautology. So I worked out with a few. So for this one, if you see A and B, we drawn the boolean truth table for that. Negation of A or B, what it would be? True, true. It would be false and true. It would be true. For true, false, it will be false and false. It will be false. For false, true, it would be true or true. So it will be true. For false, false, it would be true or false. So it will be again true. Any one of would be true, then it will be true. This is the disjunction. This become S1 become this one, right? For now, for S2, A implies B. So A implies B would be like that. A implies B is like true implies true, true. True implies false become false, and false implies true, true, and false implies false is true. What does that false A implies B in in semantic form? Can anyone explain? I'm saying A implies B. What I'm saying implicitly? Can anyone explain with the text what it does that mean? Yeah, then I'll explain what does that mean.
No, it is not known.
What did someone said? I couldn't able to catch it.
No, that's not known. Implies means if A implies B means if A is true, B is true, then
Hmm.
it is true. But
Okay.
when A is true, B is false. How it is false?
If A is true, sorry,
B
and
is false. If A is true, B is
mhm,
false. A implies B is false.
mhm.
How it is? Implies means actually what is the meaning of that implies?
Yeah, what does that implies means? Implies means if you have to break it with the equation, A implies B is negation of A or B, right?
A implies B means negation of A or B.
Mm-hmm.
So A
The,
or B is true, so negation of that is false. Here
mm,
A or B is true, negation of that will be false. So for third combination of A, B, A implies B should be false.
yeah.
But we are getting here true.
No, no, no. Let me write it and then I'll explain. So I'm saying A implies B means negation of A or B. Now you just see with all equation it will work out. So for this one, A true, B false, it would be false or true, right? So it would be true. This is working. For true,
First
false, it
one,
is false and false.
yeah, first one is okay. Negation
Second
of
one is
A or
also.
B is okay. Next one, A,
Next
B.
one is for true and false. This negation A would be false or with false. So false or with false would be false always, right?
Okay.
For false and true, it
False
would be
or
true and
false?
true. It would be true.
False means true or true? True. Okay. False, true or false is true. Okay.
So if you see
So
all four constraints is satisfying.
yes,
So
yes, yes.
similarly, we drawn both the equation here. It's the negation of A S1. We did it. So this is for S1. S2 is A implies B. We did it for S2, and then we are checking
Mm,
S1 implies S2. So it is if you see all combination are becoming true.
true.
Let me also explain. So S1 and S2 is clear how we derive the truth table for S1 and S2. Now for S1 implies S2, again you break it like that: S negation of S1 or S2.
Negation of S1 or S2.
Yeah. Now you put it here. So true, true would be false or true. It would be true.
True,
For
true
false,
only. It will
yeah,
be, and second one is also true.
yeah,
So all
true.
will be true because S2 is true for all the combinations.
Yeah. So now if you see, it would be a tautology. Tautology means for all combination, if it is become true, then it will be tautology. So S1 implies become S2. Similarly, if you'll walk over
S2.
with this Boolean zebra, you will get it which equation satisfy that. What does that notation mean? If anyone knows that S1 uh, notation means that S2 is logically consequence of S1, and that inference semantic meaning is that whenever S1 is true, S2 must also be true, and then you can draw the truth table. You will get it whether it is working or not. So this one
So,
we did it with that. So let me explain. Uh,
so which of the four answers is correct now?
Whatever is the blue color here, it is
S1 implies S2. Uh, this notation, how to spell this? Four options are given for the question.
logically consequence.
Lo-
S1 logically consequence
Logically
of S2.
consequence. Now, which answer is correct?
These all combination are true, so it is tautology. A question is asking which of the combination, which of these options are tautology. So we
Hmm.
mark it as a blue, it is true, right?
Oh,
Similarly, if you work out with this example, S1, this means the notion means S2 is logically consequence of S2. uh, Here if you have start, S2 is a logical consequence of S2. What does that mean? It means whenever S1 is true, S2 is also true. Let's
hmm.
draw the Boolean zebra and Boolean truth table and
So
see what does that mean.
the fourth one is not satisfying, no?
Fourth
S2 is
one.
logical consequence of S1 is wrong.
Sir, which one? This one.
What you said is all blue color are correct answers, no?
Yeah, yeah, yeah.
But in that fourth one is not satisfying the condition.
Fourth one means S2 is the logical consequence of S1.
That is wrong. So according to the definition, if S1, S2 is true,
Mm-hmm.
S1 also should be true. According to the definition of logical consequence,
Yeah, yeah.
if S1 is because the order is now reversed.
Mm-hmm.
If S2 is true, S1
Mm-hmm.
must also be true.
Yeah, correct.
But if you see the truth table,
Mm-hmm.
S2 is true for four combinations.
Mm-hmm.
For the second combination, if S2 is true, S1 is false.
Yeah, I mean
So
this one you are talking
yeah,
about, right?
yeah. For that, it is not in logical consequence. So S2
No,
is not
this
logical
equation is
consequence of
not.
S1.
No, no, you are comparing with this one, which is wrong here. Na? S1 implies S2. Why are you comparing with that here? The things are about S2 and
Yeah.
S1. So you should compare with these two column, not with this.
Oh, okay, okay.
So you're
So
missing that thing.
third one, and fourth column.
Yeah,
Third and
yeah,
fourth columns I have to compare. Okay.
yeah, yeah,
In either side, it is same.
yeah, yeah. So this is how you can, see which function or phi is working out. Tautology, it's very clear. Satisfiability, you will get a question. So they will give you the domain and then say whether there is a solution or not. Solution exists or not. True, false, something like that.
Okay. Right. Thank
So
you.
so also it's not about the logic. You'll also get a kind of information in text and how will you finally convert into mathematical form, process over it. This is very important. So there's just one example, proof in propositional calculus. If it is sunny today, then sun shines on the screen. If sun shines on the screen, the blinds are brought down. The blinds are not down. Is it sun? Is it sunny today? So what you do, the steps are like that. You take sentences, for express it with equation. So this is how you proceed with that. So it is sunny today. We represent it with proposition P. The sun shines on the screen Q, and R, the blinds are down. Now premise is P implies Q. If you see here, if it is a sunny today, then sun shines on the screen. So P implies Q. It is sunny today and the sun shines on the screen. Second one saying if sun shines on the screen, the blinds are brought down. So Q implies R, it is saying. Now third thing they're given, blinds are not down. Blinds are not down means negation of R. Then asking whether question is it sunny today, whatever it was there P. So we need to see whether these two equations are satisfying simultaneously or not. If it is, then we can say yes, it is sunny today, right? Like that. So this is how, if you process it and see whether finally we are coming to P or not. Did is there any doubt here? So my how we proceed with the example, you will get a paragraph like that. You need to take information, express with some proposition, and process over it. Now we drawn, truth table for prove it whether it works out or not. So PQR, there are three variables. It is sunny today. The sun shines on the screen. The blinds are down. PQR, there would be 8 combination. So n, if there are n variables, there would be 2 to the power n combinations. Now we wrote the truth values for all the premises. P implies Q, Q implies R, and negation of R. Finally we are here. Now we need to check whether question whether this are P satisfying or not. So we drawn for P, we took it there, what it was, true 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 true, false 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 false, we took it there. For negation of P also said, we checked it, we did just negation of it, false 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 and true true true. Now we are matching whether it is satisfying all these three or not. P implies Q, Q implies R, and negation of R. If you see, if you'll do AND operator here, true true true, it will be false, but P is true here, right? For other combination, if you see, with finally you need to say whether it's a P or not. Is it sunny today or not? So with this truth table, what we can convey.
Not.
It's not. It's not sunny.
It is
Right?
not sunny day.
Yeah, it's not sunny day. This is the answer. So how you proceed? Sources should be clear. So you take out the information, express with some variables P, Q, R, A, B, C, D, E, F, Z, express into equation form as we have done. P implies Q, Q implies R, and then negation of P, negation of R, and then finally whatever it's asking you say whether both are satisfying together or not. Both are working together or not. These are information-based question. What encodes grammar that represent all the sentences of a language like a propositional logic? So it's syntax which encodes the grammar. Syntax is some resonate with the grammar. Other are the information. Semantics means what information it is saying. Syntax is how it is being expressed. It's grammar, right? Knowledge base means set of information you have. Knowledge base is like that. For example, if I say knowledge base for mobile phone, so you'll have the knowledge base like Nokia, ABC, camera, how much, fast, like that, and all those. Inference engine is whatever information you will give at the inference time, how it is processing and giving you the output. So this is very classical. You need to think about that. So suppose S1 implies S2, and S1 is unsatisfiable. S1 is a formula of X and Y, let's assume. S2 is a formula of X and Y again. And S1 is implying S2. Means negation of S1 or S2 is always true. And S1 is unsatisfiable. This extra information they have given. S1 is unsatisfiable. What you can say about S2? Options are satisfiable, valid, unsatisfiable, not enough information. Can anyone answer it? Then I'll go with the explanation. And also you can think with language, right? S1 implies S2 means, let's say S1 is like rain happen. S2 is like road weights. If rain happens, it's most likely the road would wet. Now you say S1 is unsatisfiable. What you could say more about S2? So this is logical reasoning. You can think like that. So yeah, now you think and say, how can you explain it? Pretty simple. So if you see S1 is unsatisfiable, this is information they're giving, right? So P and minus P, it is not at all satisfiable, right? True, then negation would be false, and its and would be false. If I'll give, let's say P is false, then false and with true, it would again be false. So S1 couldn't be satisfiable. What you can say about S2, it could be true and false both, right? It could be false and true. You cannot say anything about S3, so not enough information to give more judgment about S2. Give judgment about S2. This is the summary of this question. So you go very, take step by step. It's like atomic process you should follow and do like that. So this kind of inference, whatever I have done here, you will not get in one or two class. Whenever you do few problem, then you'll get the idea how to go about that, how to take the boundary cases. So boundary cases are very important to take up on it, because it says whether it's satisfied. Unsatisfiable and tautology kind of thing. Even though you don't do the Boolean zebra truth table, you can easily say no, it's not possible, something like that. So these are more of an intelligent case. How will you do if you have the boundary cases like that? There are few equations and things, information with like GSAT is a greedy satisfiability is an example of which of the following, whether it's a local beam search, hill climbing with the random restart. So hill climbing, oh, it has been taught in the class, I think third week. Yeah, third week or something. Simulated annealing. So it is asking GSAT, greedy satisfiability is an example of which of the following: local beam search, hill climbing with random restart, or hill climbing with the random walk. So answer is, hill climbing with random walk. So answer is 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 hill climbing with random walk. and the explanation is given here. So greedy satisfiability means you have to satisfy the thing, but don't try all the combination. You should have some heuristic, which is like a greedy. You will be greedy to check whether it's satisfiable or not. This is known as a greedy satisfiability. In GSAT, algorithms start with a random, generated truth assignment, and then iteratively it flips the truth values of the variables in attempt to find something, assignment works or not. And each step, you flip the results and maximum increase in the number of satisfiable clauses. So very you need to know, as I said, what is the greedy satisfiability. You have to satisfy equation, check out whether the variables assignment leads to the formulation satisfaction or not, but in a greedy way, in with some heuristic. So hill climbing is similar thing. You do the hill climbing with random walk. You know what is the hill climbing? So hill climbing search, if you remember what it is all about. There was local stuck problem, and there we went to hill climbing thing. If you could remember. Okay, so this kind of question would come there. It's not like you'll get the question only from week 7, week 6, or week 3. They'll merge concepts from week 3 to week 7 and then make a question about that. So how you connect all dots is also important. For example, here they have given, if you don't know what is hill climb, you cannot relate with that. Or what does that mean with the GSAT and how it is related. So that you need to have a better idea about that. So in summary, I'll take this slide and I'll give what does that.
So what are the questions you are now discussing?
Yeah.
Can we get those questions along with solutions? Now, whatever you are showing, that everything can we get from anywhere?
Yeah. Sure. I'll share this slide, and they usually share the slide with you, NPTEL team.
Okay. Okay. Right. Thank you.
Yep.